This is Chapter 5 review from the COVID-19 homework in Honors Algebra 2 Pre-Calc. This is page 399, number 31. Okay, so this is a proof, right? It's one of these trig proofs that's asking you to show that one side of this expression equals the other. So in general, we leave the side that looks nice and happy and less complicated alone. So in this case, that's going to be my left-hand side. So I'm going to kind of lock this as like a locked box, and I'm going to try and change the right-hand side so that it looks like this left-hand side, okay? So I'm going to do that with mostly a bunch of factoring and a little bit of substitution. So I'm going to inch this over a little so you can see what's on the other side. So the first thing I want you to notice is that there's already a sign that's factored out of this entire long parenthetical expression, but you can also take out a cosine squared. So the reason that that's worth noting, right, is that if I were to, I'm going to put that sign at the front actually, and I'm going to yank out the cosine squared that's a GCF of the parenthetical expression. And what's going to be left is a 1 minus a 2 cosine squared x plus a cosine to the fourth x, okay? So here's why that's useful to know. I say, oh look, I have a cosine squared that's factored out now, and my final answer also has a cosine squared that is part of this product, right? I also have one of the signs, and there are 5 of them here because it's sine to the 5th. So my brain says, oh hey, yo, this must be a sine to the 4th, right? Like this has to be a sine to the 4th degree. So then our job is to think how, right? Now, a lot of these proofs, you're kind of reverse engineering them when a teacher asks you to use them. So the next thing my brain thinks is, oh wait, hey, hold on, this is kind of one of those secret quadratic trinomials. So this is definitely not a polynomial, it's a trigonometric expression, but if we were to use U substitution, right, so I'm actually gonna write this for a second in a different way. So I'm gonna inch over here, give myself a little bit of space, and we're gonna talk about this 1 minus 2 cosine squared x plus cosine to the 4th of x, right? So let's rearrange it so it's in order of degree. So wouldn't I get cosine to the 4th x minus 2 cosine squared x plus a 1, right? Now let's let u be whatever this middle term is, because that would normally be my linear term in a classic quadratic trinomial. So let's let u be cosine squared of x, right? Then wouldn't u squared be cosine squared squared, which is cosine to the 4th x? So isn't this expression actually u squared minus 2u plus 1? Well, that is what we call a perfect square trinomial, right? Perfect square trinomial. It's a PST. You could sing some Michael Jackson and go PYT if you wanted, even though it's PST. But so this factors into u minus 1 times u minus 1. And you can check that by foiling, right? If you were to FOIL, you'd get u squared minus 2u, because you'd have a minus u and a minus another u, and then plus 1. So this is actually a u minus 1 quantity squared. Well, if we look at it that way, then what I'm really looking at is a cosine squared x minus 1 quantity squared. Okay, so now let's go back over here with that information. So I've now got that this is a sine of x times a cosine squared, both of which I want to keep, times this cosine squared x minus 1 quantity squared. Well, we know a Pythagorean identity that is going to allow me to replace this with a negative sine squared x. So I know that sine squared, we use theta just to be clear that it's not the same exact problem. Sine squared theta plus cosine squared theta is 1. That's one of the big trig identities we want to know. So if I subtract the sine over and bring the 1 over, I'm going to get cosine squared theta minus 1 is the same as a negative sine squared of theta, meaning I could replace this entire thing with a negative sine squared of x. So now let's do that. If I do that, I get that this is a sine of x cosine squared of x times a negative sine squared x quantity squared. Well, when you square that negative sine squared x, you're going to get a sine to the 4th x, and the negative is going to disappear because you're squaring it. So this is now a sine x cosine squared x sine to the 4th of x. If I combine my sines at the front, because I now have 5 of them total, I get sine to the 5th of x times a cosine squared of x, which if we come back over here, is exactly what was originally on my left-hand side, right? And so that's my proof. And then I can do my proof mic drop, which is QED, to be like, yo, I proved this. I'm awesome. The end.